We're talking about classification. We're talking about climatic classification. We've just now finished talking about climatic classification of Coppens. Yes? Coppens, I would say, made a very landmark thing where he decided to regionalize climates. And for that, what did he use? He used vegetation as a criteria. Because he had the vegetation as a criteria in his mind, he was able to find out the climatic regions of the world. And yesterday, when we were talking about the qualities of an ideal classification, what should it do? It should clearly identify the regions. That is called differentiation. Yes. Second thing is, it should have a real-world correspondence. Because Coppens kept vegetation as a criteria, he had the real-world correspondence also. It should be universally applicable. It should be simple. It should be flexible. It should be scientific. On the scientific front, where it was cause and effect relation, we found that this is where Coppens classification was missed. However, being a pioneer in this work, Coppens has to be given that credit that he has worked. Today I want to talk about Thornthwaite. And Thornthwaite's classification has been generally a problem for many students who are reading geography and climatology, because this classification is very different from what Coppens did, in the sense that it did not give us, in the end, what was desired, a climatic region. So this classification is not known for giving us climatic regions. In fact, it failed in classifying all the climates of the world, and we didn't even have a map in the end. So it is more known for what it achieved, what kind of concepts it had given, and the most important concept is the potential evapotranspiration. The most important concept is soil, water, budget. So all these things are being asked, and I would want to say that the previous year's questions which have been asked by UPSC in geography optional, relating to evaporation and precipitation, somewhere the thought of Thornthwaite has to be included. People who are including that thought are... I think this whole Thornthwaite idea, why it becomes a little complex, is that the evolution of climatic classification somewhere is connected with the science of climate, how it evolved. So with time, better instruments have come, more data is available on climate, and as a result, the climatic classifications also started relying more on statistics. So today, when we are looking at modern day climatology, some people say climatology has turned into statistical climatology, that they are just looking at statistics. And if you've seen in the last classes on climatology, I've always asked you to look outside. Look up into the sky, observe things which are happening around you. That's real world climatology. But here we are about to enter a theoretical climatology. That is why Thornthwaite at times becomes a challenge for many people. Some of you, when you were hearing about Coppens classification, his level 1, A, B, C, D, E, his level 2, which was capturing seasonality, F, M, W, S, that was okay. When I brought in level 3, hot and cold, you thought he's doing too much. And in the end, that's there. But I still believe that he's a person who already has a region in his mind. The world is in his mind because he's seen the climatic regions, and he's converting those, vegetation regions, he's converting those vegetation boundaries into climate boundaries. He's trying to give some mathematical value to those vegetation boundaries so that anyone can understand. Now here, the science has developed. The science has developed. You've heard of Penck? Penck did what? Geomorphology. Yes, cycle. Penck has contributed here also. So Penck, D. Martoni, and Thornthwaite. When these people are studying, they are also good with the idea of Coppens, that we should have climate regions, and vegetation is a very good representative of the climate. But somehow they have dropped vegetation, and instead of vegetation, they have used two other parameters. Hydrology. What is hydrology? Water available and the soil. Get that? Why are they doing that? Because Thornthwaite has a very beautiful idea over there, that all climatic variables added up together does not give a climate. Say for example, if I keep on asking you to make a weather report, yes? So at times we have seen our weather report is dead, outside is something else. Yes, on a weather report you tell me the temperature, maximum, minimum temperature, the wind velocity today, you tell me the pressure, you tell me the humidity, you tell me the UV index, you tell me the cloud cover. That's all in the classroom. And when we look outside, the climate looks totally different. Not the climate, the state of the atmosphere, weather looks totally different. So Thornthwaite said that this very easy thing which was taken, that a climatic region is temperature and precipitation and you're adding them up, is a wrong thing. He says you need to see that if you are keeping even plant as a representative of the climate of that area, the plant does not try only on temperature or only on precipitation. It takes a lot more. Just to give you an example, how do we measure precipitation? I did not ask you units. How do we measure it? Rain gauge. We measure it by rain gauge. So precipitation can be measured. Temperature can be measured. Perfect. So he's okay with that you've taken temperature and precipitation value, they can be measured and you gave some values. But does a plant grow? Does a plant grow only on the basis of temperature and precipitation? The plant loses water also. And how does it lose water? Evaporation in that area and transpiration. Sadly, there is no way precisely to measure that. Evaporation, how do you measure that? The loss of it. So plant is not growing just by the receipt of it. Just imagine, I'm talking about the income and the expenditure. I'm talking about a budget. And in that budget, I know the income very precisely. Expenditure is not known. Yes or no? I can say in civil services preparations, most of you know the income, how much time you have. Expenditure, how to use that in your preparation, that is all confused. So what ends in the end is ki thoda bahut we are able to use it, otherwise most of the time is wasted. So he says, somewhere we must keep an idea of what is the income. Income is in terms of the precipitation. What are we talking of in terms of expenditure today is temperature. Remember, temperature will decide how much is the loss, but temperature is not a direct measure of the loss. Yes? Just imagine, loss of the plant. Say for example, income is whatever it is receiving. Loss of the plant when I am talking of, is it just a function of temperature or is it also a function of the wind? Just imagine, same temperature, calm atmosphere and strong windy atmosphere. Does it change or not? So he says temperature cannot be the only variable. Can I also say the humidity of the air at that time? Remember those ideas of saturation and unsaturation. If the air is saturated, even if the temperature is high, evaporation will not be that much because the air is saturated. Yes? But if the air is unsaturated, will the rate of evaporation change or not? Surface area will also change. Yes or no? So this is the idea which Thornthwaite comes up and he brings that idea. It's an advancement over Coppens' idea that when we are talking about a climatic classification, we must keep in mind the effectiveness and efficiency with which a plant uses the water available. And for this, he brings in two variables. One is hydrology, means how much is the water supply. Remember hydrological cycle? I asked you a question in previous year, 2018, what is the role of evaporation in hydrological cycle? So he is bringing precisely that in trying to give a climatic classification. So he brings in that idea of hydrological cycle, and second is soil. Remember, soils have different ability to hold water. Black soil can hold more water. Sandy soil will not allow water to be held, and because of that porosity, it will go down. So this time when he is going to classify, he is going to use two things. One is precipitation efficiency, and which he calls it as the humidity efficiency, and second is the temperature, thermal index. So he is going to, Thornthwaite's classification does is, it is also a temperature precipitation classification. He collects that temperature precipitation data, but he converts that into an index. Do we get that? And in that index, he is going to find out areas which are humid, areas which are perhumid. Remember, something more than humid is called perhumid. So there is a category called perhumid and there is a category called subhumid or semi-arid. So he'll arrange the world into humidity provinces. Now that's amazing. That's a very big improvement over Coppens. Remember, Coppens had 5 regions, and out of those 5 regions, one was humidity based and other 4 were temperature based. But Thornthwaite is going to convert entire world into humidity provinces. So no mixing of temperature. And humidity provinces will tell us how much water is available. If you are humid or perhumid, that means you are water excess. If you are semi-arid or arid, what are you? You are water deficit. Better? So rather than talking about 5 climatic zones and 4 are only temperature based, and one is only humidity based, he divides the whole world into humidity regions. There is a formula for that we will be looking at. This year, 2019, we have a question where they precisely asked us the formula or the methodology used by Thornthwaite, which makes it a little mathematical. And our job in the class is to make that thing easy for you, so we will be writing those formulas. Now, that is the supply side. Humidity level gives us an idea of the supply of water. He creates another index, which is called the PE index, in which he is talking about how much is the loss of the water using temperature. Get that? In that, he brings in the idea of, remember, megatherm, very hot regions, mesotherm, microtherm, ecistotherm. So rather than dividing the world into A, B, C, D, E on the basis of mixed either temperature or humidity, he has separate classification for the world in terms of humidity. So humidity provinces are there and thermal provinces are there, and when you bring them together, you will get what is the supply, what is the demand. If they are balanced, moisture balance is there. If their balance is less, it is called moisture deficit or moisture excess. Do we get that? So this was done in 1931. And remember the third variable which Coppens used, seasonal variation of rainfall, that also was there. So he added one more index on that where he talked about, remember, summer deficit, winter deficit, and rainfall full year or deficit full year. So we will be looking at that also. That's his 1931 classification. What am I trying to do is that when I talked about Coppens, you had a particular way of thinking and you were just thinking that this is about table making. Thornthwaite's classification is not about table making. The questions are not asked about his table. The questions are asked about his ideas. Do we get that? This was 1931 classification, and that ends. After 1931 classification, he is thinking again, and then he realizes that this idea where I have divided the world into thermal provinces, temperature-based provinces, and humidity-based provinces is not enough. And he finds that, just imagine, just to give you an example on this, I require some amount of water every day. My water needs are there. Does my water need change with season? Yes or no? Does my water need change? So a single human being's water needs will change with season. And let's have it, we are around 150 students sitting in this class and hundreds of them listening to me on the video. Do all of us have different water demands? Yes? Are they related to the availability of the water in this building? Maybe, maybe not. But that's my demand, yes or no? If I don't get it in this building, I'll go somewhere else, I'll purchase somewhere else if I can purchase, yes or no? So here, he says that till now we were studying only variables of water available and the heat sucking that out. These are both external variables, but plants themselves have a different need or not? Say for example, if I have a tree, if I want a tree to come up, I require a lot of water. So in the tropical area, in the subtropical area where the rainfall is above 100 centimeter, trees can come. But imagine if I put a cactus in a humid area, the cactus will start wilting. A lot of water will create problems for them. Yes or no? So he said that till now I was collecting data on temperature and precipitation alone. Today I want to collect data on the plant's need also. Now, I am suddenly going to the plant's need, and I am not talking geography, I am not talking climatology, I am talking botany. He is not talking about the climatic regions, he is talking about the botany. He wants to know what is the demand of the plant. So we'll have to study a lot of plants. We may not study, probably the data is available from the botanist. Yes or no? Have you heard of eucalyptus tree, which is called an ecological terrorist? Yes. Why? Its water demand is very, very high. It picks up a lot of water. So now in his classification, which is going to improve his previous classification, in 1948, he comes up with a new thing which is called evapotranspiration. Till now, what was it? Thermal and precipitation. Now he comes to evapotranspiration. What is evapotranspiration? Evaporation and transpiration combined. Evaporation and transpiration combined means evapotranspiration. Does it signify the loss? what will the loss by the plants be dependent upon? One is temperature. Okay, what else? Wind, absolutely okay. Humidity in the air? Yes. Plant cover. If the slope is completely or the field is completely covered by plants or it is barren, does it make a difference or not? Land use. Yes. So multiple factors. So he said, stop just talking about thermal, temperature and precipitation. Let us talk about individual plants and their water needs. Now that's a very challenging thing. That's a very challenging thing. How do you measure the water needs of a plant or evapotranspiration of a plant? How much will it lose? Remember, there is no device, there is no method to find out. There is a method called, there is a technical method that is called vapor transfer method. How much vapor is transferred by the plant to the atmosphere? How do you measure it? Challenging area. Challenging area, going into the studies of agriculture, going into the studies of soil, going into the studies of botany, and leaving behind what? Geography. And we are studying geography. Yes? So evapotranspiration, just to give you a simple example, evapotranspiration is your water needs. Yes? So how much water do you need normally in a day? 4 liters. Daily you take 4 liters or it's going by the book? Okay. What's so special about 4 liters? Why not 3 liters? Why not 5 liters? You don't eat food that much, that is why you take 4 liters of water. Why not 5 liters? You don't eat food. Why not 5 liters? And she, being a woman and having a particular height, will have some requirement which is healthy for her body. Can I have another girl who's probably taller than her, built is more something, and her water needs will change or not? Will it change with gender also? Will it change with gender? A man's body requirement, water requirement, and a girl's water requirement. Can I say, will it change with the race also? Can it change with the race? Europeans, their water requirements, and the people in tropical areas, their water requirement, will it change or not? Now that's very strange. Thornthwaite is getting into something which is going to make his life very difficult. He's going to find out what is the loss of a plant, evapotranspiration loss, when he doesn't have specific measures to do that. So he created his own formula to find out evapotranspiration. And Thornthwaite is not the only person who has given that formula. There are other people also. So I want to know your capacity. One is, she's taking 4 liters, absolutely okay. But is that optimum for your body? Do you know that or not? You do not know that. Are there some people who can tell you what is optimum for your body? Some people can tell or not? Some people who are nutrition experts, they can tell you? Yes? So now Thornthwaite is trying to find out what is the loss, optimum loss of a plant. So I want to know that capacity. How do I get to know? So how much? So how much can you drink? Now drink is a dangerous word. Drink is water. And people have different capacity. Yes, in college we start with Dhakkan. Or probably vapors first. You open the bottle. Chad gaya yaar. Vapor also. Then you go for the cap of the bottle. Yes? Then you start going into the glass. Then the glass turns into patiala. Then it turns into quarter. Adha. Then pura. Yes? And then what? There are some tankers, yes? They look at the bottle and the bottle is bottoms down. Yes or no? Aisa hota hai nahi? How do we get to know the capacity of a drunkard? How can we know the capacity of a drunkard? There are some people jinko dhakkan bhi chadta hai. You give them a lid and out. How do you get to know the capacity of a drunkard? Pila ke dekhte? So now that's a challenge. That's a challenge. So I put a bottle. Now this is a class going on. You'll say, "Arey, precipitation ki jagah now it's alcohol." But I just wanted to know that because I am bringing Thornthwaite in that. He says one thing is called evapotranspiration. Evapotranspiration is actual evapotranspiration, means how much you lose. And there is something called as potential evapotranspiration. Potential evapotranspiration is your capacity. How much a plant can lose. And I always believe that eucalyptus has a higher potential evapotranspiration compared to a cactus. Yes? But how do I know that? How do I know that? Maybe cactus can also drink more water. It's just that we've seen cactus is found in deserts. Cactus is found in deserts. So that's why I'm assuming that the cactus evapotranspiration must be lost. Remember, we have must be less. We have learned that the cactus adapts, its leaves turns into thorns, and it turns its stem becomes fleshy, and the waxy coating. All that is okay. Evapotranspiration is less because that is what I have been told. But how can I know that? What is, if I am comparing eucalyptus and cactus, who has greater evapotranspiration, or that word which is called potential evapotranspiration, who has greater? How do I get to know? So as she said, that if you want to know the capacity of someone, offer him the alcohol. Yes? Offer him the alcohol, a bottle of it or a glass of it. Bottle से capacity पता चलेगी? Glass or bottle? There's some people in the class, sir, bottle? Give me the bar. Give me the bar. दोनों glass भी दो, bottle भी दो. Okay. ऐसा वाला नहीं होता. Direct bottle nobody takes. If I want to find the capacity, first of all, I'll have to give him the whole bar. That's my capacity, no? Suppose you give me one bottle and I consume that, I will be intoxicated, no doubt about that. But was that my capacity? Was that my maximum limit? I don't know. You would get to know only if you give me more. Only if you give me more. It should be when I say no more. Or maybe I am still saying more, but you can see that I've already turned into peacock wala more. Yes or no? That's what we are looking at. So now the word potential evapotranspiration is the maximum loss that a plant will make. Now for that I must give him or it, because plant is that, give it an infinite supply of water to know how much will it have. So suppose I give infinite supply of water to cactus, I give infinite supply of water to eucalyptus. Yes? And then observe who has taken more. Who has taken more? That uptake of water will reflect the loss. Evapotranspiration, that will tell me who is more. Just imagine, like I'm again saying, like somebody who's a big time drunkard. Yes? He reaches your party and there are 10 people in the party and there is one bottle. He looks at and he suddenly feels, oh my God, this party is useless. There are 10 takers and there is one bottle. Only he knows that. Yes? And there is this person who's never had alcohol and he comes to that party and he sees a bottle. He says, oh my God, one full bottle, we are 10 people. So does it depend on the capacity or not? So he says, in my 1931 classification, I stupidly divided the world into moisture adequate, remember, high moisture and high thermal, not taking into account the actual demand of the plant. So in 1948, he said, I want to find the demand of the plant. Just imagine the word which was semi-arid. Word which was semi-arid. Semi-arid means there is a stress of moisture in that. But if you put a grass on that, grass is happy. In semi-arid, if you put cactus, for cactus, what is it? It is moisture excess. So he says in the previous one where I was talking about moisture adequacy or moisture efficiency, he was not talking of adequacy, he was talking of moisture efficiency, and I declared some regions of the world as humids, per-humid, and some regions had arid and semi-arid. I think that was wrong because the level of moisture will depend, its adequacy has to be kept in mind. It will depend upon the plant's nature also. And how can I find out plant's nature? I need to find out this thing which is called as potential evapotranspiration. Potential evapotranspiration in UPSC has been asked as a question itself. Why am I talking all this without giving you formulas? Because when people are looking at such a video or doing that, by this time they are expecting, why isn't he giving us some formulas? I am saying UPSC is not asking those formulae. UPSC is asking the concepts which are there. So what is potential evapotranspiration? The question was, what is potential evapotranspiration? And you have to write 150 words on that. Now 150 words on that cannot be just the formula. Potential evapotranspiration, can I say, is it a very clear measure of the demand of moisture by a vegetation, by a plant? Yes. And it will also measure whether that area's water supply, vis-a-vis the water supply, is that a situation of moisture excess, moisture deficit, or moisture balance? Get that? I do not know whether it can be used in climate classification or not, but I am very, very sure Government of India, who has to look into which areas are drought prone areas, which areas are flood prone areas, such a knowledge will help. Such a knowledge will help or not? And I also want to tell you ecological issues. Ecological issues, if you have an area which from Thornthwaite's idea has been declared as moisture inadequate. What do I mean by moisture inadequate? Your potential evapotranspiration is very high, very, very high compared to the moisture available. And that depends on the crop. That depends on the crop. So should you grow sugarcane, which is a water intensive crop in Maharashtra, Vidarbha and Marathwada? So that idea, because that is a semi-arid area, that is the leeward side of Western Ghat, it is a water stress area, why would you grow sugarcane over there? So that idea again becomes very, very important. And I told you climatic classifications have various utilities. So what was Coppens classification? A simple classification. He looks at the vegetation region, converts them into climate regions. And we can see them, we are very happy with this. But this one is having practical utility. Based upon your based upon your climatic region, or whatever he is talking about in terms of that moisture adequacy, can you decide the cropping pattern? Can you decide the cropping pattern? Can the planners, can the managers, can the policy makers of a country, can they decide which areas are semi-arid? For which area, what kind of help we should be given? Which areas are flood prone? Yes or no? They will plan that also. I also believe that there is something called as groundwater harvesting, rainwater harvesting, something of that sort. Not groundwater harvesting, it's groundwater recharge and rainwater harvesting. So the government is promoting groundwater recharge. They want the groundwater to come up. Now if we are in an area where potential evapotranspiration is very high, yes, soil loss is there, so there we must monitor the groundwater. But if we are talking of Bihar, which is having floods, we are looking at that is a net positive area. There if you pull out even the groundwater, no problem. Even the groundwater, no problem, because recharge is going to happen. Every time it is a moisture excess area, recharge will happen. But if you are pulling out groundwater mindlessly from Punjab and Haryana, that's going to create a very big problem. Do we get that? This is where we are relating practical with theoretical. So Thornthwaite is not thinking about Punjab and Haryana. He is wanting to give a climatic regionalization to people, and this climatic regionalization is not just based on temperature and precipitation. It is more based on the efficiency, effectiveness with which a plant uses them. 1931 he sticks to that efficiency, effectiveness. 1948 he graduates that idea to the next level, where he comes up with an amazing thing called as evapotranspiration. And its two variant. One is actual evapotranspiration. Actual evapotranspiration means aaj party mein kitna pee ke gaye tum. Actually, how much did you consume? And potential is what kind of a bevda you are. Maximum limit that you can take. Yes. Many people don't try the limit. So how do you try your limit? As she said, bhej do. Pee aaj koi dikkat nahi. Pee le apna ghar samajh ke piyo. Get that? So this is the idea. This is the philosophy behind Thornthwaite's idea. If we are working on the classification, now I'm going to give you the classification. First, this has to be clarified. Is everyone okay?